All right, thanks. Thanks for coming. Thank you to Joe for inviting me. It's a pleasure to be here. We have negative 20-degree weather, so I'm very happy to have this 90-degree differential. I would like this to be an informal talk, so if you would like to ask questions, please just raise your hand. I have some notes, but I'm going to try and make it less formal. All right. So today what I really want to do is pull together. I'm starting to pull together, so you're seeing a work in progress, a thought in progress, I suppose, of 3 different lines of my research that I've been doing in geladas. So geladas, as probably most of you know, are old rump monkeys. They are close relatives of baboons, and I've been studying them now for 8 years. I can't believe it's been so long. So what these 3 different lines of research share in common is that they all represent these changes in female reproductive condition. So I'm looking at changes in all the different females after a male takeover. And what I'll suggest by the end of the talk is that they might share another thing in common, something I'm calling the physiological trifecta. I'm suggesting maybe, and I don't have any real evidence for this, but I'll hand wave a bit, I'm suggesting that they share a physiological mechanism. All right, so I'd like to start just by telling you a story, just to give you a sense of the flavor of what goes on in a gelada group. I'll tell you about a particular male, Gabon. He's the dominant male, he's right here. He's the dominant male of a harem of 6 females. He's what we call a leader male. Now, in his harem of 6 females, he probably has females at any of the 3 different reproductive conditions. He probably has some cycling females, some pregnant females, and some lactating females. He is likely to hang on to this unit, we call it the 1 male unit. He's likely to hang on to this unit for about 2 to 4 years. And if, in fact, he's challenged, which he was on this day, he will probably have no warning. And this is important for what I'm about to say later on. We don't see any signs that this male is about to be taken over. There generally isn't any lead up, and the entire takeover takes place in a matter of hours. So within hours, he's overthrown, and he no longer has reproductive access to the females in his group. Now, nothing I've described so far is all that unusual. I think polygynous 1 male units are common across primates and across other mammals, and takeovers happen, and this is the story. But what seems to me to be unusual is that we see immediate changes in female reproductive condition following these takeovers. So as I said, we have lactating females. These are very obvious because they have an infant who's suckling. Pregnant females, which unfortunately are they're harder to assign. We generally assign pregnant post hoc, but I'll talk about that problem. Maybe I'll have time during the talk, but you can ask me about it later. Pregnant females are harder to assign than they are in typical circumstances. We also have cycling females, and geladas, unlike baboons, their sexual swellings are around their chest. So they get this sort of necklace of beads that swell when they're fertile. And finally, I didn't really mention them, but we also have immature females, and these females will come into play towards the end of my talk. So after takeovers, we see something really unusual. And the reason I brought up Gabon is because he's the first male that we saw this in. We noticed it for Gabon, and we remarked upon it. But then as we watched takeover after takeover after takeover in our 8 years out there, we saw that the same thing kept happening. Mainly, everybody starts out in these different categories, but by the end, they're all swelling. And it seemed like chance the first time, but it started to look less and less like chance as we moved on in our research. So what is going on? And this is what has been motivating my research questions lately. First of all, just what happens? Let's systematically document this. Let's not just talk about it as an anecdote. What happens after male takeovers for females in each of these reproductive conditions? Okay. So we'll look at lactating females, pregnant females. Cycling females don't need to be talked about because they're already cycling, and so we'll talk about immature females. And of course, we care about why. Why is it adaptive? What is the reason for this? And I'll give some data that relates to why females might change their reproductive condition after takeovers for each of these stages. But I'm also going to try and answer the question how. And I actually won't give you any satisfying answers to the how. I will try. This is where I'd like my research to go. So most of the how part will be, as I said, hand waving. But let's start with lactating females. Okay. So why should takeovers affect lactating females? Why should they start cycling, or at least appear to start cycling? It's important to note that all of the infants that these lactating females have when a male comes in were sired by the previous male. So the male who comes in is not the father of any of the infants in the group. And this is a problem for the new male. Remember, as I said, the new male will only have a tenure of anywhere between 2 and 4 years, occasionally less than a year. So it's a big variability, but on average it's about 2 to 4. Now, the interbirth interval for these guys is huge, about 2.5 years, sometimes more closer to 3 years. So if a male comes in and allows these, most of the females in the group will be lactating or pregnant. And so he has much less reproductive success if he waits for those infants to be weaned than if he kills them. And so if he comes in, kills these infants, he then has a chance to mate with these females much sooner than if he had waited otherwise. So infanticide is a likely scenario for geladas. And of course, infanticide by males is actually a very common reproductive strategy for a lot of male mammals, especially so among male primates. Just a bit of background. Infanticide by males was considered to be a pathological behavior way back when, until Sugiyama in 1965, and then later followed up by Hurdy in the 70s, proposed that in fact this behavior is not pathological. It actually represents a sexually selected strategy by these males to increase their own fitness. And so you get males killing unrelated, dependent infants when they come into a group. This then accelerates the mother's return to conceptive cycles. And thus the infanticidal male is able to mate with this female and sire the next offspring much sooner than if he had waited for these infants to be weaned. So, as you might imagine, losing an infant for a primate is an extremely costly endeavor. They've invested highly in every single infant, so it's probably not surprising at all that these females should develop counterstrategies to infanticide, this whole sexual conflict battle that's going on. So, female counterstrategies to infanticide, and this is more generally, this isn't so much geladas, can be classified into 2 forms. There's prevention strategies, so these are attempts to prevent infanticide. And the other class is mitigation strategies. And these are 2 classes that I kind of came up with. They're not, there could be other possibilities, but it seems to me that for the most part you can separate them into these 2. Mitigation strategies are attempts to mitigate the loss. So it's going to happen anyway. How can we minimize the damage? And so some of the prevention strategies include enlisting protection, sometimes from other females, more likely from the sire of the male. Another possibility is to confuse paternity. And this generally is this principle that a female should mate with as many males as possible so that they all have a non-zero probability of being the father. And this could minimize the possibility of any one male killing the offspring. It also could increase how many males protect that offspring. But another possibility is to produce a signal of false fertility. Now, I say this doesn't necessarily have to be in a primate with sexual swellings. The ones that it's been studied in the most happen to have sexual swelling. So it's the idea that you can decouple the signal of fertility from actual fertility. And in many cases, this is a sexual swelling, but it could also be behavioral. So many females can behaviorally solicit mating with a male, even if they themselves are not fertile. Now, importantly, these strategies allow a female to continue to invest in her current offspring. And so these strategies sort of represent this low cost as long as they're successful. But they tend to be more risky. Now on the other side, mitigation strategies, one possibility is to wean the infant early. If a male comes in, depending on whatever signal he's using to identify whether a female is receptive or not, if it has to do with just being able to mate with her, well, maybe it makes sense to hurry your current infant up, wean them so you can mate with the new male. Kind of related to this includes this category that's not been observed that often, which is sort of abandoning an infant. So even at a very young age, just completely abandoning them and mating with the new male. And finally, another strategy for a pregnant female is it's sort of the equivalent of abandoning a live infant, is to abandon a pregnancy and to abort and start over with a new male. Important for this other side is that this the female is shifting her investment. She's cutting her losses. She is no longer investing in the previous infant. She is just cutting her losses and starting to invest in the new infant. And of course, these are thought to be high-cost strategies, but they're a sure bet. Okay, she's just saying, I'm going to cut the time it takes rather than try and wean this infant and wait and see if they get killed. I'm just going to curtail any investment and start over with this new male. Okay, so how do these counter strategies relate to geladas? Well, there's several characteristics of geladas that make them really likely candidates for one or more of these counter strategies. The first one, as I've already mentioned, is that they live in these polygynous harems, or one-male units. These units comprise of a dominant male. Yeah, I sometimes say dominant male, and I'll sometimes say leader male. 1 to 12 related females, and their dependent offspring. Now, despite their name, about a third of our one-male units include another male. We call this a follower male. Actually, it can include anywhere between 1 and sometimes 5 of these follower males. These are subordinate males that hang on in the group. They're often the deposed leader, but they don't have to be. At the periphery of these groups are bachelor males. They congregate together in these all-male groups, and these are the bachelors. These bachelors are just waiting for their chance to challenge and defeat one of the leader males. So that picture I showed you of Gabon, the other male, that was a bachelor male challenging Gabon. The challengers always come from these bachelor groups. Now, we've done some genetic analysis, and it's really important to know that all of the offspring that have been sired in these one-male groups have been sired by the males in those groups. Generally the leader male. The leader male sires 80% of them. However, for about 17%, we noticed that the follower males are getting some reproductive success. But the important thing is that none of these offspring came from outside the group. There was no extra unit paternity in geladas. This will come into play later when we're talking about which males a female can mate with. What are her options? Keep that in the back of your mind. Okay, so what about infanticide? Is it a selective force in geladas? Absolutely. Male infanticide doesn't just occur. It's really, really, really common, to the extent that we even could say it's expected. Infanticide accounts for 62% of all infant deaths. The infants don't really die out there, but if they do die, it's almost 60% of the time it's due to infanticide. If we do have a takeover and there's infants present, each infant has about a half chance of living. So 48% of the infants in a unit will die after a takeover. So as a result of this, we should expect counter strategies by females. This should be a selective force.
Jacinta, when the 48%
Yes.
die, is there anything that predicts which ones survive and which die? Is it the older ones who survive, or?
So, okay, well that stat is a little bit tricky to explain. Males come in and they're all or none. So a male will come in, he'll kill all the infants, or a male comes in and he doesn't kill any.
Oh, okay.
We rarely see it where there's a mixed strategy. could say more about that, but I'll wait till after. Okay, so a little bit about our study population. Our field site's located in the Simien Mountains National Park. It's in northern Ethiopia, they're in the highlands. We've been at this site now for 8 years, and this is, sorry, that should say 8. 8 years of data, and this is sort of what it looks like. It's more like the Grand Canyon in the sense that it's not so much mountains, it's more like we're really high and the rest of the ground is falling beneath us. We sort of walk around on this high plateau of grasslands up here, and then at the end of the day, the geladas climb down on the cliffs to sleep at night. So we have demography and observations from ranges from about 17 to 21 units as a result of fissions, fusions, and groups we've just entirely lost. But on average, it's about 20 units. The data set that I'm going to be presenting today includes 145 infants, 131 females, 28 male takeovers. We have fecal hormones from a subset of these females. It's really expensive and logistically challenging to get fecal samples from everybody, so we try and really target it. Some of this is just totally serendipitous that we pick the right females, as I'll tell you in a little bit. But a lot of it is due to the heroic efforts of graduate students. And in this case, much of the data I'm presenting today was the result of Ayla Roberts' PhD thesis. And she collected a zillion samples from 5 units in particular that included 25 females, and she did estrogen and progesterone. She also did glucocorticoids, but I'm not including that in the story today.
A zillion.
All right, so what happens after takeovers for lactating females? We're still on the lactating. So if we examine their first postpartum return to fertility, so it's just a histogram, here's the number. This is the month relative to takeover. So I don't have 0 on here, but if you can imagine a 0 right here, this was takeover, I think this was the takeover, and then you can see a disproportionate number of females returning to fertility in the month following a male takeover. Keep in mind, these are non-seasonal breeders. Actually, maybe I didn't even say that. They are non-seasonal breeders. I'll say that now. So there is no reason to expect that this month should be any more, that there should be a return to fertility during the month a male comes into the group. Okay. So the return to fertility is more likely after takeovers, but this doesn't tell us much about any adaptive function. So I broke it up into why and how, but really it's what, why, and how. So this is the what. But let's think about the why. Why might females be returning to fertility so quickly after a takeover? All right, let's go back to the counterstrategies. So as I've said, the pattern we see is that lactating females resume cyclicity and readily mate with the new male. This is exactly opposite of enlisting protection. Rather than enlisting protection from the former male, they're running towards this potentially infanticidal male to mate with him. Okay, it's not confusing paternity, since they already have an infant, but it could be that they're producing a signal of false fertility. They're definitely producing a signal. Whether it's false or not false, whether it's honest, is what we need to determine. So that's one possibility. With respect to mitigation strategies, they're not abandoning an infant. We don't see any signs of that. And of course, that's a pregnant strategy, so that one doesn't count. So these are the 2 we care about. Okay? And as I said before, one's a low cost and one's a high cost. With respect to the low cost option, we know geladas have sexual swellings. They could be exploiting them. They could be honest. They could be deceptive. Okay? There has been some research in hamadryas by Zinner and Beehner who showed that these hamadryas females tend to produce sexual swellings in response to takeovers and that they are indeed deceptive. But we don't have any evidence. Until now, we didn't have any evidence. So that's one thing we want to look at. On the other hand, on the high cost side, the weaning an infant early, Dunbar had done, actually the Japanese researchers as well as Dunbar had reported that it appeared that these females were producing sexual swellings right when a male came in, and they proposed that they were weaning their infants early. But again, they didn't have any evidence as to whether these were honest or whether they were fertile cycles. They just showed that these females were mating with these males. So we're trying to sort this out. So how do we sort this out? there's two ways to approach this problem. So we can either address whether these sexual cycles result in pregnancy, so whether they're conceptive or not conceptive. Or we could examine whether they're ovulatory or not ovulatory. Now I'm going to approach the problem from the first, whether they're conceptive or not conceptive. And I can talk to you after about why I didn't do the ovulatory, non-ovulatory. But I'll focus on whether they're conceptive or not. So the mean interbirth interval for this population is 2.37 years. And this is sort of a schematic breakdown of how much time they spend in lactation, how much time they are cycling, and how long pregnancy is. Okay. Now, to look at our two predictions, we have this is hypothetical data. Okay, this is real data. This is from the population, all of our animals, so from 37. And these are our two expectations under our two hypotheses. So under false fertility, we expect that lactation should appear shorter, okay? And that they should basically have this non-conceptive period that appears like they're cycling, when in fact they're actually just continuing to lactate. So that it should be a non-conceptive addition that just stretches this out. But their interbirth interval should ultimately be the same. Okay, so we have this little period here about whether or not that's conceptive or not conceptive. Under early weaning, we basically expect that to be cut out. And so lactation is basically cut short. They're weaning their infant early, they begin cycling, and they get pregnant and give birth. Okay? So what do we see? First of all, I'll take it in parts. Females resumed cycling more quickly after male takeovers. So post-takeover, it was about a year, whereas the mean for the population, just to remind you, is 1.4 years. With respect to cycles to conception, females took longer to get pregnant after male takeovers, so about 0.8 years as opposed to 0.53 years. And if we put this together, we can see that the interbirth intervals were actually exactly the same for females with and without a takeover. In fact, they were exactly the same. It was just a weird statistical anomaly, but they were identical. So in other words, although females cycled much earlier, or at least they appeared to cycle much earlier, they didn't get pregnant any earlier. So these cycles were non-conceptive. Yes?
Was there any evidence of them hiding lactation events from the males?
It's a good question. I can't say that we've systematically examined that, but if I had to say from my own impressions, I'd say no. It gets into a really good question about what is it that males are zeroing in on? What is it that fools these males, or what is it that doesn't fool them? What is it that causes them to kill these infants or not kill these infants? And one of the, some people say coat color of the infant, but that doesn't make any sense because why would the infants then have those coat colors? I think probably the strongest hypothesis is that, or the one that I would adhere to the most, is probably whether a male is able to mate with that female. I think that would be where I would put my money. But again, I don't have evidence. It's just yes.
But are they still nursing? Like, do you see
Yes,
them nursing during
they're
this
still
time?
nursing.
And do they still nurse when they start cycling again? Is this
Yes,
something that
they're
always
still
happens?
nursing.
Okay.
Yeah, but they will nurse. That's not a good enough sign that they're not ovulatory. They can ovulate and nurse at the same time. In fact, sometimes we've had where they give birth to their next infant, and the previous infant still wants to nurse, even though they're 3 or 2. All right. Okay. So we have a working hypothesis of false fertility as a female counterstrategy to protect her infants from infanticide. But does it work? So our sample size is really small at this stage. But what we did find was that infants were more likely to survive if their mothers exhibited sexual swellings after a male takeover. So of the 16 infants whose mothers exhibited sexual swellings after a takeover, all of them survived. And this doesn't support an early weaning hypothesis, because if you're weaning your infants early, they should be less likely to survive. Now, by contrast, of the 11 infants whose mothers did not exhibit sexual swellings after a takeover, less than half of them survived. Okay? Now these numbers don't quite add up to the ones I showed you before because these only include, because in a lot of these cases the infants actually disappear before the mother was even cycling. So we don't include the data for those. So we're still working on this part of the story, but we're starting to figure out, trying to understand, we're actually adding glucocorticoids to this event as well, because it all kind of goes together. But I don't have time to talk about that today. Okay, now for the hand waving. How? How do lactating females exhibit false fertility? Obviously this is it's always difficult to answer how questions in wild populations, but I can at least touch upon this with some of our estrogens data, and I'll come back to this at the end. So first, here's a composite of our estrogens data for a typical ovulatory cycle in blue. So this is a mix of cross-sectional and longitudinal data, and you can see the ovulatory peak, and this is surrounded by quite a bit of noise, which is not unusual for fecal hormone profiles. But to help sort through some of the noise, I'd like to draw your attention to the green bar here. This is the estrogen mean with the standard deviation, the standard error of the mean for lactating females. So when you have a lactating female, this is where it is. It just bounces around between within this little green rectangle. So you can see that this is significantly higher than that. And I've carried the rectangle over, so you can still see where the lactating mean should be. When we look at the females with this deceptive or these swellings, we can see that they are significantly higher than what you'd see for just a regular lactating female. So any lactating female who has a swelling has estrogen activity going on. We've never noticed this peak, but that could just be a sampling error, so it's difficult to say. But we do see that the estrogen activity is much higher in females with sexual swellings than it is with lactating females now. Okay, so let's move on to pregnant females. Pregnant females are also at risk for infanticide since their infants were sired by the previous male as well. So what counterstrategies do pregnant females employ? So as I said before, we have no evidence for the first two preventative strategies. But females who are pregnant can also produce false fertility. They could produce sexual swellings, making the male, and confuse, and in this sense, sort of confuse paternity. Okay, so on the other side, obviously these first two have to do with being lactating, but the last one, terminating pregnancy, could cause a female to abort, to curtail investment in her current offspring and invest in a future offspring. And this is a phenomenon that's known as the Bruce effect. And the Bruce effect gets its name from a biologist by the name of Hilda Margaret Bruce, who more than 50 years ago demonstrated that pregnant female mice will terminate their pregnancies if they're exposed to a new male. So since these initial experiments, the Bruce effect has mainly been experimentally confirmed across dozens of rodent taxa and entirely under captive conditions. And there have been some wild reports of a Bruce effect in wild horses, in lions, a few primates that include Hahnemann-Langers, yellow baboons, and geladas. But all of the evidence so far has been either anecdotal, where they just report that there's been an abortion after a takeover, or it's been indirect. So basically a dearth of births during a period when there should be more. So even though there's been a bounty of support for the Bruce effect in the laboratory, there's really been no direct evidence for this that came from a wild population. And some have even proposed that a Bruce effect is just a laboratory artifact. It's just something that's created in the laboratory and it doesn't actually have any adaptive or evolutionary significance. Okay. So once again, though, we have a low-cost and a high-cost option. So first we tried to examine pregnant females after takeovers to look at whether or not they exhibit false fertility or not. But there were no pregnant females. Well, actually there were two. So here I've lined up all the births that took place in units relative to a takeover. So the line is the takeover, and these are the months before, and these are the months after takeover. And as you can see, we just have this kind of, rate of pregnancies that go on, and then suddenly we have this big gap, and then we have more births again. Before this line, all of these infants were sired by the previous male. And the gestation period in geladas is 6 months. And so any pregnancy, any infant that was born after this time would have still been sired by the previous male. At 7 months and on, all of those infants have been sired by the new male. So what's interesting here is that even for this non-seasonal breeder, we have a statistically significant dearth of births in the time following a takeover. So in a non-seasonally breeding species, 5 years of data, more than 100 females, and 28 takeovers, we have 2 infants. So now, interestingly, if we just look at these 2 infants, which is all we have, one of the females swelled, and her infant lives to this day. She swelled and she mated with the male, and another of the infants did not swell, and her infant was killed the day after it was born. So that's all anecdotal. We can't actually analyze that statistically, but at this point, we can say at least there's a possibility for females to use sexual swellings as a false fertility signal, but we don't have the data. It doesn't seem to be a common strategy. Okay. Okay, but what about the other side of things, terminating pregnancy? There were anecdotal reports of a Bruce effect in geladas. It was reported by Maury and Dunbar in 1981. So these observations were obviously suggestive and intriguing, and we ourselves had seen an abortion following a takeover. A female just gave birth to a deformed fetus, and we knew it was an abortion, and it was the day after a takeover. So we were curious about this as well, but we wanted to investigate this systematically. Could a Bruce effect be a systematic response to takeovers in female geladas? All right, so to figure this out, we compared all units that had experienced a takeover with a control group that had not experienced a takeover. And we did this to just match up group for group, that had about the same size females, to compare the births during the same time of the year for groups that had and had not experienced takeovers. And we did this to control for this slight seasonality in births as well as takeovers that we see. And this is what we found. Huge differences. So this is a lot like the figure that I showed you previously. It's centered on the time of male replacement, but this time I binned things into basically into the number of births for when there wasn't a male replacement and the number of births for the units that did have a male replacement. And you can see here there's no significant difference in the number of births. In the 0 to 6 months after, so these are infants that are sired by the previous male, we see the two that I showed you before, those are here. But the no replacement male, the groups that did not have a male replacement were statistically non-significant from any of these other groups. And in the 7 to 12 months after, there's almost like a makeup period. The females are all getting pregnant, mating with the new male. Okay. So this is compelling data, but again, this is just indirect evidence. It really isn't any different from a lot of the evidence that had been presented previously, especially from lions. Lions had showed the same result. What about direct evidence? And this is where our hormone data really pay off. Remember, I should say that pregnancy was really hard to detect in these guys. They're really fuzzy. They don't really get big like pregnant females should. So there isn't really a reliable signal. So we actually have to use ovarian hormones to detect pregnancies. And we identified all hormonally determined pregnancies across the study. So that's for units with and without takeovers. We found 60 of them. Now 51 of these pregnancies resulted in a successful birth. So we knew our method was working, but 9 of them ended in an abortion. And of these 9 abortions, 8 of them occurred in the day or two after a takeover, consistent with a Bruce effect. So here's this figure. We have fecal, these are just 3 sort of representative cases of females from this population. This is their fecal estrogen level, This is the days relative to the male replacement. Here's the takeover with the line. We've centered them all on the same period, even though they took place across different periods. The estrogen levels rising as consistent with pregnancy. And what I'd like you to note from this slide, and the thing that really struck me, I literally had tears in my eyes when I saw it, is how we kind of knew there was a Bruce effect. We thought, well, we're probably going to be able to show it. But what we didn't know is, one, how prevalent it was. Like that 80%, and I think much higher, 80% of these females were aborting. But even more remarkable is the timing. They're pregnant the day, the male comes in the morning, they're pregnant at that point. By the end of the day, they've aborted. It's so fast acting. And it doesn't matter what trimester. It could be in the first trimester, the second trimester, or the third trimester. And we see abortions in all 3 trimesters. Really astounding. We were not expecting that. All right, so females terminate pregnancies after male takeovers. Yes?
I was just wondering how good males are in keeping their tenure once they come in. Is there a way that another male will come in and oppose them in, say, 2 days or something?
It's possible. So we do have these chaotic periods. There seem to be 2 different. Let me just make sure I understand your question. You were asking how do males?
The new male.
How does he make sure he keeps the unit?
Yes.
The takeovers fall into 2 groups. There are what we call just normal takeovers, and then we have these chaotic, messy takeovers. So we have clean and messy. The messy takeovers are not that common. The messy takeovers tend to be this period of total chaos where it's not clear who the leader male is. There actually will be many males kind of hovering around a group, sometimes mating with these females until things sort out. We don't have that many cases of these messy takeovers, and we tend to just keep them separate. And it would be nice to sort of analyze these separately. But for the males that have these clean takeovers, they're then there, and they are the leader for 2 to 4 years. I don't think I've answered your question about how. I just know that there seem to be 2 types.
What I thought your question was going to be is, do you ever get a comeback by the previous alpha? Because
Never.
we get that situation a lot,
Aha.
and that's why I think the females really struggle to defend their infants for a while, even though it's hopeless in the long run.
Never have we seen a male, once he's defeated, he literally quits. I've seen it. The male was fighting for 3 days straight, and there was a point where he just said, oh yeah, so I'm done. And he just collapsed, and he just started being subordinate to the new male. We've never had a male, if a male is there for a few days and gets overthrown, or if he's there even for a month and gets overthrown, he often will go back. If he hasn't sired any offspring, he'll go back to his bachelor group, and he might try again. But generally, the males that hang on for any period of time and have offspring, I've never seen a male get overthrown and come back.
Okay, well that makes sense then.
Yeah.
And how soon after they take over are the infants killed? Is this something that happens during the conflict?
That's a good
with
question.
males,
Yeah.
Or does it happen like long?
It always happens in the first 2 months. It usually happens in the first 2 weeks. But we've seen a few cases where we've kind of kept it open for about 2 months. Yeah.
That's right, and you said that all the takeovers occur from males coming from the bachelor groups, so there's no threat from the subordinate males within the group.
Never. And in fact, in the Hamadryas baboons, the subordinate strategy, this follower strategy, is a way to kind of either pair off a few females, maybe the leader male's offspring, possibly if he sees a weakness, he can take over. So as a subordinate strategy in Hamadryas baboons, that seems to be a possibility. I think when Dunbar first started studying the geladas, he was using that Hamadryas model, and he even said that follower males might be able to do this. Never. We've never seen it in 8 years. A follower male is like a follower male, and that's it. It's a substandard strategy, but if you've been dealt a bad hand of cards, it's better than nothing. All right, so is it adaptive? Okay, so here we have interbirth intervals on the y-axis, and we have different events on the x-axis. So when an infant survives to weaning, the interbirth interval for this population is 2.37 years, the same number I gave you before. Okay, so not surprisingly, when an infant dies between successive pregnancies, her inter-birth interval is much higher. Now keep in mind, these are inter-birth intervals between one successful infant and the next successful infant. Okay, so the one that dies just gets added to the time. That's not the actual interval. So it's success to success. So obviously if the infant dies, you have a much longer inter-birth interval. Now, that's not surprising. But what is surprising is when we compare the mean interbirth interval for the population to the mean interbirth interval for those experiencing a Bruce effect. Now, remarkably, these are not all that different. It's 2.65 compared to 2.37, okay? So in other words, a Bruce effect only tacks on an additional 3 to 4 months. By contrast, females that lost their infant tacked on an additional 16 months. Okay. Now, even if we correct for the odds of infanticide, which are about like 48%, the interbirth interval for females that don't abort and take the risk of infanticide is still 2.95 years, which is still higher than either the population mean or the Bruce effect interbirth interval. Okay, so in other words, I've been saying that these mitigation strategies are high cost, but perhaps counterintuitively, it appears that a Bruce effect may not actually be that costly after all for gelada females. And this constitutes some of the first evidence that this might be the case. Okay, how? This is the question that everyone wanted to know when we first published this data was, how do they do it? And of course, the media wants to know if it's conscious. It's so hard to even explain that. But how? That's my big question. I really want to know how as well. How do females terminate these pregnancies? And I can't say yet what the mechanism is, but I can obviously speculate. So there's several possible mechanisms that could be operating. The one that everyone zeroes in on is the stress response. So this is the idea that if an organism is under stress and produces lots of stress hormones, then the body should curtail its investment in all non-essential activities, reproduction being one of them. And so then the individual female might be expected to abort as a result. But I actually think that the stress response is unlikely. I can talk more about this after, but I think it's unlikely to be this sort of classic model of a stress response. And the reason I think this is twofold. One, the females that abort are not being beat up by this new male. There doesn't appear to be any real aggressive threats. Now, this is very different from what's seen in these yellow baboons. And I don't know if anyone has read this Pereira study, but there is an account of abortion following the entry of a new male into these yellow groups. But this male beat the crap out of these females. I mean, this male really wrung these females over the ringers, and they aborted as a result. As a result, I do think that Pereira article of this terminating pregnancies in yellows is a fundamentally different phenomenon than what we're seeing here. So that example, and maybe other examples like it, I think represent this. Okay, like 2 weeks later, the female aborts as a result of this male beating up the female. We're definitely not seeing that, absolutely not. But the other reason why I think the stress response is not a likely mechanism is how fast it's happening. Remember I said the male comes in at the beginning of the day, she's aborted by the end of the day. It just doesn't seem, this kind of speed with which it's happening does not seem consistent with what we see. That's not to say it's not, I think it's unlikely. We tried to look at glucocorticoids, but because of the timing, we don't have enough sampling in that time. And I can talk to you more about that after. Okay, what's another possibility? Yeah.
You're actually observing the abortions?
So, no. Occasionally. We've seen a few. We've seen 3, where the female literally has a fetus in her hand the next day, and it's not a fully developed infant. We're seeing them through hormones. Okay. Yep. And we're seeing them indirectly through statistical argument. Okay, so the speed of the Bruce effect that we're seeing seems to be more consistent with what we see in rodents. And what we see in rodents is a chemosensory mechanism. So based on these rodent studies, this mechanism requires some chemo signal, and these are also called pheromones. And this signal comes from a novel male, and he induces a Bruce effect. So what might this chemo signal be? Well, in mice, it might be estrogen. And so you get this, there have been a lot of studies that would come out of Catanzaro's lab, and these are really recent studies, 2012, 13, where he is able to inject these mice with radiolabeled estradiol. He injects the male. The male then excretes it in his urine. The radiolabeled estradiol is in the urine. He then traces this radiolabeled estradiol into the vomeral nasal organ of a pregnant female. It then travels through her system, and he finds radiolabeled estradiol bound to her reproductive tract, all the way down to being bound to her uterus, causing her to abort. And it doesn't take much estrogen. Just a tiny little rise in estrogen in a pregnant mouse can cause her to abort. So there's been this really nice demonstration of estradiol literally coming from a male mouse and entering a female mouse and causing her to abort. Now, of course, if you've been paying attention, you're probably wondering, wait a minute, how does a female know whether this estradiol is from a novel male or from the sire? So if she's still with the sire, he might be also excreting estrogen. How does she keep that from causing her to abort? And as it turns out, these pheromones are linked up with these urinary proteins. And the urinary proteins, some of them they think that might be related to MHC, allow her to recognize her mate. And there's a mate recognition system that occurs at the level of the VNO where a female can allow this neuroendocrine cascade to occur or not allow it to occur. So recognition is an important piece of the puzzle that goes along with the pheromones in the urine. If only I could do all this in geladas, that would be wonderful. Okay, so females process chemosensory information from recognized males differently than they process the same chemosensory information from an unknown male. Okay. Now, I really think that the idea that hormones pass from a male to a female is really cool. But there's something even more cool about this mechanism. If pregnant females get estradiol from a novel male, they terminate pregnancy for a Bruce effect. But what's also been shown in mice is that if immature female mice get estradiol from an unknown male, they mature earlier than they would have otherwise. And this is what's known as a Vandenbergh effect. So this effect gets its name from John Vandenbergh, and he discovered that immature female mice reached puberty a lot faster when they were housed with a novel male as when opposed to when they were housed alone. So it's been proposed that, and this is again that same group, Catanzaro, I can never say his name right. He's proposed that the Bruce effect and the Vandenbergh effect go hand in hand. They piggyback on the same mechanism in some sort of pleiotropic effect, or at least they do in mice. So this got me thinking, of course. You know, we have a Bruce effect in geladas. We do see what, and then I'm getting ahead of myself. Let me stop. Okay, now the flip side of the Vandenbergh is females also can delay puberty in response to other chemosensory signals. And I'll talk about this in a bit too. So we need to know if it's a delay or an acceleration. Okay, but what's the adaptive significance of a Vandenbergh effect? In other words, like, why should pubertal timing for these young females be sensitive to these social cues? Now, in rodents, the consensus hypothesis is that if you have a small rodent and they have really short life histories, accelerating reproduction when presented with a breeding opportunity, so these cues from these novel males, can give females a jump start on their own reproduction. And this is really important if you're in an unpredictable environment where you don't even know if you're going to run into a male. So, is this going on in primates? Do we see anything like a Vandenbergh effect in primates? Now, there have been some data that come from callitrichids. No one uses the term Vandenbergh. This is not a term that's ever been used in primates. But we do have some evidence of what appears to be Vandenbergh-like effects. From callitrichids, the data almost entirely overlap with what we see in rodents. Exposure to a novel male can accelerate puberty, and exposure to a dominant female can delay puberty. There's also one report of novel males accelerating maturation in a galago, but among catarrhines, we only have one other example of what appears to be a Vandenbergh effect. And this comes from a captive study on Hamadryas baboons, where they found that introducing a new male caused the immediate maturation of 4 immature females. But that's it for primates, unless we can add geladas to the list. Okay, so let's go to immature females here. Why might immature females be maturing immediately after a novel male arrives? I kind of gave you that preview slide that said everyone starts swelling. Could this be a Vandenbergh? Well, let's just look at the what first. Oh, sorry, I'm giving you a little more background, just to lay down the foundation. Okay, so immature females might actually reach an age at which maturity should be expected, even when their father is still the male in the group. So I'd said that the reproductive tenure was 2 to 4 years. That's where most of them fall. But occasionally we get the max male tenure of over 4.5 years, which is when females mature. Max male tenure 5.5 years, it's now 6.5 years. This is a little outdated. I should have updated the slide. It's unbelievable. We can get some really long male tenures at one end of the spectrum. The mean female maturation is 4.5 years, so we will occasionally get cases where a female's dad is the only male she can reproduce with. Remember I said extra male paternity, there's no extra unit paternity in the group. Females do not mate with males outside the group. So she either can mate with her dad or she can mate with a follower male. We do see a little bit of differences when there is a possibility of her mating with the follower male. But most of these groups do not have follower males. Most of them are 1 male units. So she doesn't have any choice. So this suggests that females should be sensitive to these changes when they occur. Okay, so what happens? What happens to immature females? Let's just look at the data. We see that female maturations are a lot more likely during the first week after takeover. So again, centered at takeovers, the number of females maturing, here we have this statistically significant jump in how many females mature right after a male comes in. Okay, and this is just all females. We haven't broken it up. Okay, so we definitely see what appears to be some kind of Vandenbergh effect. You know, whatever you call it. There's been a whole debate about, people got mad when I called it a Bruce effect because they said, well, you don't know that it's pheromonal. And I said, well, it's called the Bruce effect, not the Bruce mechanism. So it shouldn't matter what the mechanism is, it should matter what the effect is. And the effect is that females abort. So if same thing could be applied here. This is a Vandenbergh effect. A new male comes in, all the females mature, not all, but a lot of the immatures mature. So in that sense, in some sense, I could say we have a Vandenbergh effect. I think that's a little less interesting. I think the more interesting thing is then to show why, adaptively, and how, mechanistically. So moving on to the why. Why do immature females exhibit a Vandenbergh effect? This is our project right now. We're in the middle of this, and this is taking years and years and years. And the reason is because it's not neat like the Bruce effect. The Bruce effect is measuring the occurrence of or not of an unlikely event. So if it happens, you can look at what that means for the animal versus when it doesn't. We're trying to measure an event that happens for everyone, and we're just looking at the timing of it. And of course, the timing of maturity can be affected by all kinds of things: access to food, rank, anyway, a whole bunch of things. So, and we're looking at a lot of them. So we're trying to pull apart how the timing of maturity, how that is affected by one thing in particular, which is a male coming in, against the backdrop of all these other things that can affect female maturity. Okay, so so basically females might mature early. Now the benefits to maturing early is that they might have an earlier first birth, but of course life history theory predicts that there should be some costs, such as stunted growth or slower growth. Maybe they have a slower reproductive rate and possibly a shorter lifespan. They could mature late. The benefits to this would be that they could avoid inbreeding. Maybe they'll end up at a larger adult body size, which then could translate into reproductive success later on. The cost is possibly a later first birth. These are all the things we are looking at and we care about. The only thing that I'm going to show you data on today is this yellow one, the fact that they could be avoiding inbreeding. So why do immature females exhibit a Vandenbergh effect? So we see that no females matured while their father was the only male in the unit. None, never. Unbelievable. So we never have seen a female mature while her father was the only male. When their father was replaced, we get a staggering jump in the number of females maturing. Okay, so the three striking results of this. 1, none of these females matured while their father was the leader male. 2, many of these females matured immediately after their father was replaced. And 3 of the latest maturations recorded for any female in our population are in this group. So these results are suggesting rather than an acceleration, which is what's proposed for rodents, we're actually just seeing a delay. But in any case, it's still suggesting these social effects on reproductive control of a reproductive axis. That females are somehow, there's a translation of a social signal to a physiological one, which I find extremely interesting. Okay, I'm going to go through this quickly because I know I'm out of time. So why do females, do they mature early? Do they mature late? We're trying to collect growth data. We're also putting this in the context of life history. And this is just to give a plug to Amy Liu, who's doing a lot of this work in collaboration with me. We've adopted a non-invasive method of getting growth data using digital photography and parallel lasers. So we have a camera with 2 lasers mounted on it. It then projects, it puts 2 green dots on the animal if they're in quadrupedal stance. We then have a photograph where we know this is 4 centimeters. Is that 4 inches? 4 centimeters? I think it's 4 centimeters. And then 4 inches. Sorry, I can't even remember. 4 centimeters. That just looks bigger than 4 centimeters. And then we can use Adobe Photoshop to actually measure these animals and get stature. So we're looking at growth. And in a very short time, this is actually outdated already, we can get a growth curve. And so here we have all these animals with known ages, and we can get their growth. We know their known ages, and we have their shoulder to rump length. And we can look at a growth curve, and then we can start mapping on these life history variables like age at first maturation and age at first birth. Okay, so all of this has to be in the context of life history data. But we're still a long way off. The adaptive significance of a Vandenbergh effect has to be in the context of all these long-term kind of variables, which means it's a very long-term project. All right, so back to the how. Okay, as with the Bruce effect, there might be a chemosensory mechanism at work here, but catarrhines don't have a functioning vomeral nasal organ. Not at all. I don't know, maybe mandrills. I don't know. They have something weird going on. So if they don't have a functioning vomeral nasal organ, I mean, they could be picking up pheromones through some other source. It could be the main olfactory epithelium. It could be through the skin, possibly through the sperm. I don't know. There could be some other mechanism by which chemicals are exogenous. They're coming from the male, being transferred to the female. However, I think it's more likely that there's some social mechanism, possibly chemo, but it could be some social mechanism that is causing the female's own endogenous estradiol to go up, which then contributes to a Bruce effect and or a Vandenbergh effect or sexual swellings. Okay, so to summarize, so lactating females exhibit false fertility. They produce deceptive sexual swellings. Why is this? If mothers swell, infants are more likely to survive. Pregnant females pregnant females will terminate their pregnancies in response to a new male, known as the Bruce effect. And why? If females abort, their interbirth interval is not significantly longer. Immature females, they show a Vandenbergh effect. Why? Could be that female sensitivity to new males helps them avoid inbreeding. There may be some other factors at work here as well. Now the how. And this is sort of putting it all together. So to begin this talk, sort of the end of the talk where I began it, I'd like to sort of think about the fact that maybe all of these are related to a common mechanism. Could it be that all these females resume sexual cycling through some kind of mechanism that causes their estrogen to go up, known as a physiological trifecta. And so the sort of support for this is that in rodents, new males cause a Bruce and a Vandenbergh effect. These two piggyback together. So they are linked in rodents. And this is mediated by estradiol. Now in primates, new males cause a Bruce effect. They also possibly cause a Vandenbergh effect, at least in the geladas, and deceptive swellings in females. Primate sexual swellings in general are known to be mediated by estrogens. And this is a point that I like the most, is that this Colmenares and Gomiendo paper of 1988 showed that, it's the same paper that showed that when you introduce a hamadryas male into a new colony, these 4 females immediately matured. He reports 3 things in that paper. One, he reports a Bruce effect. He doesn't call it a Bruce effect, but he says after introduction of these new males, a bunch of females aborted. He also reports that these females matured. Finally, he also says that a bunch of lactating females resumed cycling. He didn't check to see if they were conceptive or not conceptive, but they resumed cycling. They showed signs of sexual swelling. So hamadryas have the same trifecta as geladas. So, let's see. He calls it, so when he talks about these 3 things together, he uses this term called the hoo-ha effect. Now, Dunbar also uses this term to refer to the same 3 things, because there had been anecdotal reports of this. So I looked this up in the Urban Dictionary. I don't know that I want to revive this particular term once I found out what it means, but I do think that there maybe could be some kind of inclusive term to refer to these 3 things that might go together in certain species. Now the hamadryas still need confirmation that some of these other things are occurring, like the Bruce effect and like the Vandenbergh. But I think the social systems predict that this should be going on, that these things could go together. And I think that's it. So again, a lot of hand waving, not a whole lot on the how, but this is where I'd like to kind of find out some more stuff. And I've been really lucky to have a great team of researchers, all the people contributing to the Gelada Research Project, my Ethiopian counterparts, all the funding. And I thank you guys all for listening, and I'm happy to take questions. Yes?
So let me take a page out of your book and suggest another complementary explanation for the Vandenbergh
Sure.
effect here, in addition to inbreeding avoidance.
Yes, is what I want.
Which is, I don't have all the details and numbers in my head, but the interbirth interval was somewhere between sort of 2.4 and 4 years typically for the females, right? That is, 4 was on the outside. And the male tenure was between 2 and 6 years. So if I'm a female and I'm, maturity is on my horizon sometime in the not too distant future, and there's a takeover. If I mature now, I can conceivably get 2 offspring out during the tenure of the new male. Mm-hmm. If I wait, then the best I'm likely to get is 1, right? Because the second one is likely to be a victim of infanticide or a
Right.
Bruce effect, depending on where I am in the process.
Right.
So basically, when the takeover happens, the gun starts for the window during which I can produce offspring prior to a likely fatal end for the conception, right? And so I should begin as soon as possible.
Right. Actually, I definitely think you're onto something. It's hard to separate out the sort of adaptive, or let me just say this other thing first. So I agree. I think that females are, when a male comes in, there's enough of a social trigger, or at least it seems like it would be adaptive for them to immediately start reproducing at that time. A male comes in, you reproduce, because on average, their tenure, the female interbirth interval is 2.5 years. On average, the male tenure is about 3 years. So it makes sense that a female should basically reset the clock, mate with this male, carry this whole offspring to completion just in time for the next male to come. So probably not 2, but certainly 1 can fit nicely into that if they literally reset at that moment.
Or if she waits 6 months or a year,
Yes.
she's not even
And-
gonna get that one.
And we're starting to look at seasonality in these guys, and we do see that there's not only a seasonal, there's no mating season, there's births all year round. But we do see a slight seasonal peak that makes sense in the terms of like all the seasons. But we also see if we don't look at the group as a whole, and we look at each group as a unit and standardized by unit, we also see a seasonal peak that relates to when they've been taken over. So basically females tend to kind of all come together and reproduce at the same time, more or less. It's a little bit messy because these lactating females aren't actually resetting their clock, they're pretending to. I'm not getting at the answer to your question though. So your question is, you're suggesting that the trigger for these females to, but either way it's a social trigger to mature
Sure,
by a
but-
new male.
But the point is, I agree with you that their costs in
Aha,
terms
but
of, say,
my-
total adult body size, but if I wait 6 months or a year, I achieve a larger body size, but my first infant is dead because he's not gonna survive
I
the
see.
takeover
So
at the end
so
of it.
the
So it's worth the cost of maturing early if I'm somewhere within the maturation is on my horizon, I'm somewhere within some
Right.
window of when I could mature.
Yes.
It's worth maturing immediately as soon as there's a takeover.
And I think, and that's something we'd like to look at. Right now, we've only been able to address the inbreeding, kind of avoiding inbreeding. Whether or not females, so what we'd like to ascertain, and right now we don't have any evidence of this, but we need more data, is whether any females are accelerating. So do we get both ends of the spectrum, as we do in rodents, of acceleration as well as delay?
There's a cost of waiting, so if dad's around, I'm paying cost of delaying and waiting for the new male, right?
But the inbreeding cost is higher
Yeah,
than the delay,
that's right,
so then
that's right.
that makes sense.
Yeah, yeah.
But the other side of the equation
It's an
is,
acceleration.
if you accelerate, you mature, are you then stunting your growth? Because that's sort of the whole life history trade-off. We don't know, and that's where the growth data comes in. Great.
Just out of curiosity, looking at the 3 tiers of females that you presented, is there any significant difference between the timing of swelling after a takeover? So, for example, do immatures swell before, say, pregnant?
Aha, I see what you're saying.
Or is it all like this, they all kind of...
Well, so the abortions happen immediately.
Sure.
But then it takes
sure.
them about 2 weeks to start cycling
Okay.
again. The immatures, it's within the month. Like the scales were always a little different based on what was the most, what I felt the most confident putting down there. Because when we talk about maturations, it was a monthly scale. And
Right.
within the first month after takeover, you saw a bunch.
But it's not like all at the same time, they all start swelling.
It seems like it. When
Yeah,
you're watching the
it does.
group, it's like
Okay.
2 weeks later, everyone's
Sure.
swelling, and the new male's mating with everyone.
Yeah.
So there is sort of a really striking,
That's
anyone out there would see that as
Right.
happening.
interesting.
So I guess, I don't know if that answers.
So you mentioned this time where you watched a male give up after 3 days of fighting. And I was wondering, did you class that as a messy takeover when that happened? How did it go on?
No. So actually, I did not count. So that one we did not count as messy because it was a clean takeover once it happened. But that would be a case, we didn't actually have hormones from that takeover, but that would be a case where there was some warning. It would have been interesting to see at what point, any females who did abort, at what point,
That was my question.
at what
yeah,
point
because-
during that. And we don't have our data's not refined enough to get at those sequential kinds of things. We weren't looking for it at the time. Now that we have this huge statistic that so many females abort following a takeover, we're getting a lot more detail surrounding the takeover. So the idea is, all right, a male comes in. How long does his takeover take? In most cases, it's hours. That was sort of an unusual one. Although, yeah, that was sort of an unusual one. But then at that point then, we want to kind of get at this sequence of lactating females. At what point do they start sort of swelling and soliciting male attention and mates and grooming? How much contact does this lactating female have with this new male in terms of any kind of chemical signal between them, as well as the pregnant females? So we're trying to get at a little bit more fine-grained with our timing of the events between the takeover, the swelling, and I guess takeover swelling. 'Cause that's pretty much what we care about, from takeover to swelling, what's going on in there. and
Because
how
even
it's.
if you don't have, say, the former alpha taking back over, like we do with the capuchins sometimes, if you have this drawn out fighting, and if the former or the current male actually wins after 3 days, then these females
Okay.
3 days of queue
So
would be like.
that's a good point. Here's one thing I should say, which is so bizarre. There are no failed takeovers.
Okay.
It's so crazy. Maybe we've seen in 8 years. Now, to be fair, a failed takeover might be much quicker, and we might miss it than a successful takeover, which is very salient and goes on for at least a couple hours. Whereas a failed takeover might be a quick attack that takes a second and we miss it. So we could be missing them, and we have seen a couple. But in 8 years, we've only seen about 2 or 3. So we just don't. I think what happens is these males are just at the end. You know, they've been maintaining this group for long enough, and they just can't really do it anymore. I think that the bachelors are targeting. They have these sexually selected signals. It's chest patch and these loud calls, and I think the bachelors kind of know when a male's at the tail end of his ability. The bachelor males also have these strategies, and this is a whole nother talk. These bachelor males will chase the male. They'll take turns chasing him until he's exhausted, and then one bachelor male will move in for the kill. Sometimes literally the kill. So they're once they're targeted, they're pretty much over. You know, we know that once we see the bachelors targeting a male, that his end is in sight. Yes.
Oh, do these bachelor males have some common characteristics, like their age?
Yeah, and so that was the whole project of a graduate student of mine. He's trying to see if it's this pyramid structure where you graduate the top guy and the other guys move up, or are they competing it out too? To be honest, we don't have a satisfactory answer. It does seem more like they're cooperating than that they're competing, and that they kind of know who the next male is.
We kind of suspect in our all-male groups that they seem pretty egalitarian, and we can't tell who's going to emerge, and we're not sure they can either.
Huh, we should talk.
They save the fighting it out between themselves until after they've taken over, and then you often get really bad fighting within the alliance.
So
They've evicted the resident males.
they've evicted the resident male, but there's a bunch of males that come in together, and then they quickly fight it
Yeah.
out. Aha. So we will see bachelor males coming into the group together. So if there's going to be a subordinate follower, he comes in with one of his other bachelors at the same time as the takeover. We never see followers join after the fact. They always join during a takeover, and they're usually a buddy of that guy.
Okay, yeah.
But they don't fight it out. There's actually a lot of love between males. There's not a whole lot of fighting other than this leader male bachelor fight. The bachelors don't fight. Once they're in the group, the leaders and the followers groom. And
So, like, I'm really curious about this question of a mechanism. I know it's hand waving and everything.
no, I know. I want to actually nail it down. I don't want to leave it. But
Yeah.
I don't know. There's only so much I can do.
Oh yeah, I mean,
In
it's
the wild.
interesting to speculate though, because you've got all 3 classes of females being affected by this. So is there some kind of behavior that the male is doing to every female that's in the group, like immediately after takeover, that could be the transfer medium of possibly this estradiol?
Okay, so there are tons of primates have lots of estrogen in their armpit. In fact, if you do a swipe and run it through, test it, it'll be really high in estrogen, probably for the men in this room. And they groom armpits constantly. So this is something I was saying about trying to get at the timing. The male takes over. How quickly are those females grooming him, touching him, in contact with him? Or do we see sexual swellings while the females have never really had that much contact? Like, I'm so much more interested in that interaction, and that's what we're developing now. We just don't have the resolution in our behavioral data at this point to get at that. So it's something we're focused on quite a bit now. I really want to know if it's a chemical transfer or exogenous or endogenous. Which one is it? One interesting thing about the hamadryas is if we can demonstrate all these things in hamadryas are not endangered. So suddenly it opens up a lot of possibilities for captive studies, whereas geladas, that's never going to happen. So I'm hoping that what we see in hamadryas is equivalent. So then I can start, there's some populations like it's not called the Southwest Foundation, but whatever it's called now, Texas Biomedical, where they have maybe not hamadryas, but at least they're hamadryas hybrids. There's a possibility that something might be going on. Now what I didn't mention, sorry I just thought of this, is that chacma baboons also have infanticide. They have infanticide is common, and yet you never see a Bruce effect in chacmas. And so, you do have these species, closely related species differences that relate, I think, if I had to throw it out there, to social structure. So the chacma male tenure is about 6 months. Their interbirth interval is 2 years. So a female is likely to see 3 to 4 different males during one interbirth interval. If she aborted every time a male came in, she'd never have any offspring. We actually have this going on in one of our gelada groups. There's this one group that's huge. It's gotten way too big. And the males keep taking it over. Literally every 8 to 9 months, the group's been taken over. It's just this one fluke group that there has not been a birth in more than 3 years in that group. So this is post our data collection, but it's just been crazy how these takeovers. So I could see this, if this happens and this is common, you could see there's probably selection against a Bruce effect. And so I imagine or selection for, I don't know which direction it's come from, but it's a conserved, I would imagine it's a conserved mechanism. It just, depending on the social structure, it goes one way or the other.
You mentioned earlier that not all new males that enter a group are necessarily infanticidal. Is there any research, or do you have any ideas as to what causes some males to be infanticidal and others not?
Yeah, that's a great question. Joe and I were talking about that earlier. It's actually a perfect question for a PhD student. I can only speculate. I don't know for sure. Because it is so variable, there has to be some advantage. Otherwise, it's one of the big questions. It's always advantageous to kill offspring if you're a male. You should always come in and just kill all the offspring. Always. Unless there's a flip side. So maybe somehow bonding with those females, creating a social bond of some sort, gives you a longer tenure than if you kill the infants. If I had to speculate, there's this whole spectrum. It's basically a continuum. But at the two ends, you might have these two different strategies. The one strategy is you take a large group, lots of females, you kill the offspring, you do the best you can in the short time you have, because those groups get taken over quite often. The alternative strategy, the nice guy strategy, you take over a small group, and you try and cultivate bonds with those females so that they want to keep you around. And you are a nice guy, and you actually, those are literally the group that's 6.5 years and 5.5 years, those are the small groups. Those males have these smaller groups that are in less demand, and the bachelors aren't really scouting those out as much, so they end up with these longer tenures. So maybe that's a better strategy if you're not infanticidal.
So do the females have any influence on the likelihood of the new male taking over or not?
That's another good question. If you just sort of watch from the outset, you might say no, because the male comes in and he decides which group and he takes it over. But I think they do. So we're actually looking at some of these questions now. We're looking at bachelor social knowledge. How much do bachelors know about what's going on in each of these groups? And one of the questions is whether or not bachelors can tell if females and males have a good or a bad relationship. As researchers, I know when a female and a male have bad relationships. So there's these certain groups, and the females just hate the male. And it's just really obvious. Any of you guys out there, we know it in a second. But they bicker, there's just always chaos. And then there's other groups where they just love him. They're grooming him. So you get this sense of close relationship, not close relationship. Surely the bachelors, who have a lot to gain from paying attention to this kind of knowledge, should capitalize on it. Demonstrating that's a little harder to do. That's just my opinion. But
how much is known about these ornaments and what they indicate about male competitive ability? Is that the signal that these bachelors are using to know when it's right for a takeover? I'm just struck by this incredible discrepancy between my population and yours in the successive takeovers once they happen, because we have so many failed takeover attempts.
Yeah, it's remarkable. I would say yes. I'd like to say unequivocally, I think these sexually selected signals. Are there any possibilities out there for a capuchin signal, sexually selected signal?
No.
The males who come in, do they know those males? Would you say, if you had to guess?
In intergroup encounters sometimes, and so in intergroup encounters, after there's a lot of branch breaking and displaying and vocalizing and dancing. So they try to get to know one another a little bit in the intergroup encounters, but there's certainly nothing physiological that would be an indicator.
One thing about this population is they're so big, so many animals, that individual recognition goes down. They probably don't have a lot of individual recognition. In signaling theory, you tend to get signals developing in species that have very little individual recognition, so they need these signals to then make these decisions of mating or fighting. So I'd like to say that the red chest patch is a badge of status, and the males know when the male has dipped in his redness, and that's when they go for him. The same is for these loud calls, and these geladas have these ritualized loud calls where it doesn't usually end in aggression. It's just the leader male will leave his females, he'll go up to a bachelor group, and he'll kind of like, come on, follow me, and he'll just run, and all the bachelors run. But it's not a chase, it's not like they actually want to catch him. It's they're all loping. It's just this ritualized chase where he runs up and down the mountain, they run up and down the mountain behind him, and they're all like, I mean, they're not running to get away. And at the end of it all, he runs up in a tree and he gives 3 or 4 yow, yow, yow at the loud call. And the bachelors are all looking at him. And it's like they're taking notes in their notebook, kind of like, all right, keeping track of how agile and how, the stamina of this guy. There's a whole bunch of issues with that. I have a graduate student who's on that right now. She's looking at whether the frequency of these displays matters or whether the quality of the display matters. Now, if it's the frequency, then that means these bachelors are keeping track of individuals. If it's the quality, then it means these bachelors should act on it right away. Because if they don't know individuals, then it opens up a whole new door of what the possibilities are. Where was I going with that? Okay, so chest patch and loud calls. Yes, I think that they are definitely these badges that the males are paying attention to, and that's how they determine when to challenge and when not to. I'm trying to think if I should go into this whole. Chest patch is becoming more problematic than it's not that simple. But I just for now I'll say that we have too much data. So basically what happens is if you look at the chest patch, it is correlated with, it goes down when the males get taken over. But when you look longitudinally at each male, it actually doesn't go down until he's been taken over, which goes against what I just told you. It should dip before. So we're trying to work that out. That's why I haven't published in this, like, what? Yeah. Oh, are we out of time? Sorry.